Hello, everybody. We are back with another visual pattern challenge, and this is probably the strangest one we've seen yet. Here is step one. Here's step two of the pattern. Here's step three, and here's step four. And your challenge would be to predict the number of circles, the number of dots in step five. And then if you can do that, the number in step 43, and could you write an equation that you could use to express the number of dots in any step at all? So there seems to be a lot going on here. Let's just see if we can predict step five by understanding what's going on here visually. What I see is two squares, the blue square and the green square. And to start off, the blue square is 3 by 3 and the green square is 2 by 2. And they're growing, right? The blue square becomes a 4 by 4, the green a 3 by 3, then 5 by 5 and 4 by 4, then 6 by 6 and 5 by 5. So it looks like they're increasing the size of the squares by 1 each turn. But at the same time, they seem to be moving toward each other and overlapping. So that orange represents where the squares overlap. And in step one, there's no overlap. They haven't merged yet. In step two, there's just one little dot of overlap. In step three, it looks like a 2 by 2 square, and then a 3 by 3 square in step four. So if I had to predict this for step five, and we can see the numbers are growing rapidly, so this may take us a little time to count if we do this just visually here, but I should have a 7 by 7 square for the blue. And for the green, I should have a 6 by 6 square. And this portion of overlap should be 4 by 4 because this one is 3 by 3 here. It was 2 by 2 the step 4. So I think this is 4 by 4. So how many dots is that actually? I think one good way to think about this is that you'll take the blue square and the green square, add them together. If you do that, you're actually counting the overlap twice. So you just have to subtract the amount of overlap. So this should be 7 squared, so that's 7 by 7 for the blue square, plus 6 by 6, so 6 squared for the green square, minus 4 squared for the 4 by 4 overlap. So that, I think, is one level of insight that's going to help us a lot with this. We actually pretty much have a formula here already. We just have to put in step numbers instead of just plain old numbers, and we'll have an equation. But let's actually calculate this and see how many there are. So 7 times 7 is 49, plus 6 by 6 is 36. So let's just add that. That would be 15. So 85 minus this, so minus 16. So let's see, that would be 69. All right, so we have in step five, we're predicting 69 squares. Let's take a moment and actually analyze this list of numbers. My guess is this is going to be a quadratic. We've been talking about square numbers all the way along here so far. So that's probably what it's going to be. So we'll do the step and the number of dots. And in the first one, we've got a 3 by 3 and a 2 by 2. So 9 plus 4 is 13. So step one is 13. Here we've got 16, 17, 18, 19, 20, 21, 22, 23, 24. So step two is 24. And in step three, we've got 25, 26, 27, 28, 29, and 8 more would be 37. And in step four, we've got, getting big here. So 6 by 6 is 36, plus 10 more is 46, plus 6 more is 52, I think. And then we're saying 69 for step five. So now that we've got the numbers listed out, hopefully I didn't make any mistakes there. Let's take the differences. 24 minus 13 is going to be 11. And 37 minus 24 is going to be 13. And 52 minus 37 is 15. Aha. And then if we take the difference of the differences, 13 minus 11 is 2. 15 minus 13 is 2. Aha. So the reason I took the difference of the differences is because the differences weren't a constant number, and we want to find that constant number so we can know the degree of the equation. If the differences are a constant, then it's a linear equation, a first degree equation. If the difference of the differences are a constant, like they are here, a 2, then it's a quadratic equation, a second degree equation. When this number is 2, that means you have an x squared and the coefficient is just 1. If this number were 4, the coefficient would be 2. If this number were 1, the coefficient would be 1/2. Whatever this constant is in the second set of differences, divide it by 2, and that's your coefficient of your x squared term. So that's a start on a formula, and we know we're going to have that x squared as sort of our leading term here. But instead of trying to find x squared in here and puzzle it all out, I think what I want to do is just use this intuition we had from the very beginning, that these are 2 squares minus some overlap, okay? So let's try to describe these squares. So I said it was the blue squared plus the green square minus the orange square, because that's where they overlap. Let's try to find those in terms of the step numbers. So what is the blue square in step 1? Well, it's 3 by 3, so that's 2 more than number 1, 2 more than step 1. So if we take the step number and we add 2 to it and square it, that would be the blue squared, right? So if in step 1, x is 1, 1 plus 2 is 3, that'd be 3 squared. Likewise, the green square is just 1 more than the step number, so that is x plus 1 squared. And then the orange part, well, here we don't see it until step 2, and it's only 1 by 1, so it's actually 1 less than the step number. In step 3, it's a 2 by 2 square. In step 4, it's a 3 by 3 square, etc. So this is the part we're going to subtract, I'm running out of room here, is x minus 1 squared. So this is the blue square, this is the green square, this is the orange square. We add the blue and the green, we subtract the orange, because if we don't, we've counted that orange twice, and that should be it. Now, if you wanted to leave this formula just like this, you certainly could. This has some advantages. It really relates to the visual image you're seeing here, and that's just fine. If you want to FOIL everything out and combine the like terms, I'm not going to do that in this video, but what you would get is x squared, which we expected was going to be our leading term here, and then plus 8x plus 4. So I think that's what you get when you FOIL all this out and add it all together. Let's just test this with a couple of spots here. So in number 1, in step 1, you would have 1 squared plus 8 times 1 plus 4. And that would be 1 plus 8 plus 4, that's 13. That's exactly how many we have in step 1. If we did that in step 2, we'd get 2 squared plus 8 times 2 plus 4. So that's 4 plus 16 plus 4. Yeah, that's 24. And you could go on and test some of these others. I'm confident that this or this is a good representation of an equation for this particular pattern. So I'm going to write that down. So y equals x squared plus 8x plus 4. Now, finding the number of dots in step 43, we just have to plug 43 in for x here in our equation. So y equals 43 squared plus 8 times 43 plus 4. Okay, so 43 squared is 1,849, and 8 times 43, let's see, 8 times 4 is 320, 8 times 3 is 24, so 344, I think. And then plus 4 more. If we add all that together, I think what we get is 2,197. Okay, so we got 2,197 dots in step number 43. Well, that was a weird one. Very different from the patterns we've seen before. How did that go for you? Did you see what was going on with the overlapping? Did you accurately predict 69 in step 5? Did you come up with an equation, something like this, or something different? Let me know. Thanks, everybody.